Are there any questions so far? But again, we're trying to find the percentage of data values, which is just area to the left or right of a z-score. So let's do an example. Let's do an example. So let's say the data set here that we're dealing with, right? This is example 8. Let's say the data set that we're dealing with are, again, test scores. They're out of 10. And as before, these test scores are normally distributed with a mean of 6 and a standard deviation 0.3. So this is our data values, okay? We want to know what percentage of the students scored less than 6.5. What percentage of the students scored less than 6.5? Okay, well, again, we're not going to use Desmos. What we can do is first convert to a z-score. So we have the data value, which is 6.5, right? We're converting it to a z-score, just like we did last time, as you can see. Right? You take the data value, you minus the mean, divide by the standard deviation, and this is what we end up getting about. Good. Why that negative was there. So if we were to use the table then, right, what we would do is look for the z-score here in the table, right? Wait, there we go. We would look for the z-score here in the table. But now this would not be there. Remember, in the table, it only has data values like this. You know, they're point something. They're rounded to one decimal place. Oh, wait, they can't see that. Right? If we went back to the table again, let me share this again. Right? If you go back to the table here, you can see that 1.667, I think that's what it was. That's not in there, though. But what we can do is round to 1.7, okay? I mean, we have 1.6, as you can see, but we don't have 1.667. But notice that 1.7 is 0.9554, which actually I think we said already. So that tells us the z-score of 1.7, the area to the left of it under the graph is 0.9554. So that's what we got from the table. We got 0.9554. So that's the area to the left. So the percentage of data values, you just convert that area to a percent, which is 95.54%. That's all. I mean, whenever they say percentage of data values, you're just looking for area. That's what it boils down to. And hopefully that's making sense for everyone. I really hope it is. Now, what about this one? What if they're less than 5.5? Well, it's the same idea, right? Again, you convert it, right, to a z-score, you know, just like before, right? Except now we're looking for the percentage of students that scored less than 5.5. So what do? So we want the percentage of students that scored less than 5.5. It's the same data value, so we have the same mean and standard deviation. So just like before, right? What do we do first? We go to z-scores first, okay? We convert that. In this case, our z-score is 5.5. So we find the z-score. That's what we're doing, right? we get negative 1.667. Just like before, we look for that in the table. Negative 1.667. We look for that in the table. In fact, let me go to the table actually. I wasn't gonna share the table again because didn't know if it was helping to keep sharing and not keep switching between sharing documents, but I guess I really should share the table. So let me just do that again. Oh my gosh. Right? So again, now we have negative 1.667. But that's not in here, is it? But we can round to one decimal place to get negative 1.7, and we get this, 0.0446. 0.0446. So that's what we get here. Going back to the notes, right? In that table, we got 0.0446. That's the area. So the percentage of data values is 4.446. That's what we get. So that's our area, and this is our answer. Good. All right, so this one I want everyone to try, but let me just read the problem with you. Let's suppose, this is a word problem from the book. So let's suppose the blood pressure, I'm not sure how to say that word, I should know. The blood pressure of males has an approximately normal distribution with mean 125, standard deviation 14. Now here I'm giving you the z-scores, okay? So here it's a little bit different. I'm giving you the z-scores and I want you to find the data values. Okay, so I want everyone now to try A and B first. See, we'll do these together, don't worry. But I want everyone to try these A and B first. Take about 5 minutes. Okay, let me just stop the recording. I want everyone to try this now. Again, the most important stuff is, let me underline it. No, here, right? It's a approximately normal distribution. The mean is 125, standard deviation's 14. So we want to find the data values given these z-scores. Okay, that's what we want. I think that word is systolic. I could be wrong though. Systolic, but anyway, I think you can still do the problem. So I want everyone to try this now. Take about 5 minutes. So let me stop the recording.